All right, algebra, last section in chapter 10, factoring completely, okay? There are further ways we can factor things over the set of what's called complex numbers. We are not getting into that in this course at all. So for the sake of what we're doing, we will consider a polynomial to be completely factored when it cannot be factored any further over the set of integers. In order for us to consider a polynomial to be completely factored, each polynomial factor needs to be itself completely factored. So what does that mean? Let's take a look at example number 1. Factor 5ax to the fifth minus 5axy to the fourth. Step number 1 is going to be to factor out your common monomial, which in this case is going to be 5ax. When we factor out 5ax to the fifth divided by 5ax leaves us with x to the fourth. 5axy to the fourth divided by 5ax leaves us with minus y to the fourth. Now we need to factor out the difference of squares. This right here is a difference of squares. 5ax is equal to x squared plus y squared times x squared minus squared, okay? We have another difference of squares, so we have to factor that one as well. 5ax times x squared plus y squared times x minus y times x plus y. Now we have completely factored this to here because nothing else can be factored. Okay, all of our polynomials are factored out. We are all done. Example number 2, factor x to the fourth minus 9x squared plus 8. There's no common monomials that we can factor out, and there's no special patterns. So what we need to do is we need to find the factors of 8 whose sum is negative 9. So that's going to be negative 1 and negative 8, because negative 1 times negative 8 is positive 8. Negative 1 plus negative 8 is negative 9. So we end up with x squared, because our first term is x to the fourth. So x squared minus 1 times x squared minus 8. Okay, what you'll notice, that results in a difference of squares here, because x squared is a perfect square and 1 is a perfect square. So we have to factor that binomial to x plus 1 and x minus 1 using our difference of squares rules times x squared minus 8, and now you're all done. Example number 3, factor 2xy minus 7x plus 10y minus 35. Okay, first thing we're going to do is we're going to group these. 2xy minus 7x plus 10y minus 35. Okay, factor out the x here, leaving us with 2y minus 7. What are we going to factor out here? We're going to factor out 5, leaving us with 2y minus 7. And our resulting factorization, x plus 5 times 2y minus 7. We have factored everything completely. There's nothing else I can factor. We're all done. Moving on to example number 4. Factor am minus an minus pm plus pn. Group these. Am minus an plus negative pm plus pn. What am I going to factor out here? M minus n. Then over here, minus p times m minus n gives me a minus p times m minus n, and I am all done. Factored completely. Example number 5, okay? Factor 2y cubed plus 5y squared minus 8y minus 20. We're going to group 2y cubed plus 5y squared plus negative 8y minus 20. I can factor out y squared of my first grouping, leaving me with 2y plus 5 minus 4 times 2y plus 5. I'm left here with y squared minus 4 times 2y plus 5. I am not done factoring because here I have a difference of squares. Y squared is a perfect square, 4 is a perfect square. So that is y minus 2 times y plus 2 times 2y plus 5. And now I am all done. Here are the rules, okay? I would recommend you having this sheet of rules and skimming over it constantly and memorizing what's happening here, okay? So here's our strategies for factoring completely. This is basically everything that we've done, okay, through this chapter, all right? Step number 1 is always going to be to factor out your common monomials, okay? Step number 2 is when you consider the type of polynomial that you have left once you factor out common monomials and what specific strategies you can use, okay? If you have binomial difference of squares, that factors to this, okay? When you have a perfect square trinomial where a squared plus or minus 2ab plus b squared, that ends up as a plus or minus b squared, okay? Or if you have a trinomial in the form x squared plus bx plus c, or x squared plus bxy plus c squared, you find the factors of c that sum up to b. Or if you have a resulting trinomial in the form ax squared plus bx plus c, or ax squared plus bxy plus cy squared, rewrite the middle term using the factors of AC whose sum is b as coefficients, and then factor by grouping. Or you may end up with some polynomials that you're going to factor by grouping, which is what we just worked through, okay? Continue factoring until each factor is no longer factorable. Then you know you're done, and then you can check. Okay, so these strategies are your BFFs for Chapter 10.